Greetings, I would like to bid to those who are listening to our presentation today. My name is Loretta Nayan Anadangan, 72309, and I am representing Group 42 to present to all of you the introduction of manufacturing process of a car door, together with my friend Nur Ain binti Mor Haji, 70854. There will be five topics in total, the things that we're going to present today, which is the first one, description of the product, and the second one, flow process of each component. Both of these topics will be presented by me. The third one, defects that normally occur, and the fourth one, design consideration. Both of these two topics will present by Nur Ain binti Mor Haji, and the fifth one will the optimization will be presented by both of us. I will be starting our presentation with the first topic, which is description of our product, which is the car door. So what is a car door and what are the vital components of a car door? Car door is a vital component of an automobile as it protects passengers, ensuring they are secure inside the vehicle. Car doors are also important as it serves as an entryway or an exit for the automobile, aside from establishing comfort for the passengers. Having said that, different car door components have different manufacturing processes, after which the car door components is then joined by bolting or welding them together. So shown in the slide right now is the infographic on car door components as well as the assembly of a car door as a whole product. So the first thing is the car door frame. They go through the process of casting process. The raw material is aluminum, molten aluminum, and this is the final product for car door frame. The second one is the car door panel. The raw material of the car door panel is coils of carbon steel, and this is the finished product of a car door panel inspected by a worker for any dents or scratches. For the third component, which is the car door windows go through non-metal forming processes. So the raw material is sand, but these sand are also mixed with dolomites, limestone, and also broken or colored glasses in order to stabilize the reaction. And this is the final product, the car door windows, the glasses. And last but not least is the joining process of assembling a car door. This will be the final progress of our product, which is the car door. And on to our next topic, which is the flow process of each component, where I will be explaining in details the processes, the manufacturing processes that is involved in each car door component, and also lastly I will be explaining the joining process of a car door as a whole product. So on to our first component, which is the car door frame. Car door frame goes through a process called casting process. Before starting the casting process, the die casting machine goes through the clamping process, where the die house headlamp face is cleaned and applied with ejection lubrication or release agent. The die house then closed and clamped together with pressure applied from die cast machine. The molten aluminum, as you can see in the first picture, is maintained at a temperature of 660.32 degrees Celsius and then transferred into an injection chamber, as you can see in the second picture, and injected into the closed die prepared just now. The pressure inside the closed die is maintained at 1000 psi to 20,000 psi as the metal solidifies, as you can see here in the third picture. The injection of metal into die is ensured to be short to make sure the metal does not start solidify before the die is completely filled. The molten metal is afterward let cool to solidify before the die is open, as you can see in the fourth picture, used for another batch of aluminum car door frames. Lastly, As you can see in the fifth picture, a worker arranges the parts of the frame windows that has been casted, a reinforcing plate for the hinge, and the inner door panel all in a special clamping fixture to form a car door frame. The fingers of the clamping fixture grip the parts to hold them in position as another fixture rotates, and two robots will move in to weld them together into a finished product, as you can see in the sixth picture. Our second component, which is the car door panels. To explain the manufacturing process of metal forming process of a car door panel, the material used in the process is carbon steel, a type of strong malleable alloy. A production machinery uncoils the rolls of carbon steel, as you can see in the second picture, and straightens it. Large blades are used to slice the carbon steel roll into desired lengths, producing sheets called blanks. The blanks are then brought over to a powerful trial stress, which offers a better view of the stamping process. The press forces blank into a die, giving it a basic shape of two car door panels. The design of the car door has been engineered for better aerodynamics and strength. In the production line, however, the main press churns out the car doors. An automated device with mechanical fingers then grips the newly shaped steel and transfers it into a punch cutter machine. Punch cutter machine separates the two doors and trims the excess metal from the edges. Finally, a handler inspects the outer door panel for bumps, dents, or scratches. So on to our third component of a car door, which is the car door windows. To explain the manufacturing process of a non-metal forming process of a car door window, as you can see in the first picture, sand is mixed with limestone and dolomite to stabilize a chemical reaction in glass making. As in the second picture, broken or colored glass is also added to the mixture in order to help in the melting of the glass mixture. The molten glass mixture is then left floated on liquid tin before being cut and shaped into several rectangle flat pieces. A computer-controlled tungsten carbide wheel scores the required shape afterwards. Next, a flame is directed towards the glass to create a thermal stress to crack along this core. The edges of the newly cut glass are subsequently grounded and washed and then toughened by being floated on a hot gas with a temperature of 630 degrees Celsius. The glass is then chilled rapidly to put a compressive stress to the glass, making it tougher to stand against massive impact. Thereafter, the glasses go through sag bending processes to be curved into desired shape in pairs, where the glasses are heated into 600 degrees Celsius and are bent into a mold. Thin plastic interlayer is added in between two pieces of glass and then squeezed together before being baked in high pressure furnace, which is also known as autoclave, for 90 minutes. Finally, the glass is installed in a car door by inserting it in between the car door outer panel and the inner panel, letting the inner mechanism of the car door moving the windows up and down. As in the last picture, as you can see, is the finished product where the car door windows are installed into the car door. And on to our last process, which is the joining process, assembly of a car door. In order to explain the manufacturing process of joining process in assembling a car door together, it starts off with arranging steel bars and tubes on a robotic platform as they add strength to the car door. This way, the car door can withstand stronger impact from surroundings. The car door frame from the earlier process just now is then placed over the bars and tubes. A robotic platform angles the parts to weld them together, forming an inner panel of a car door. Next, another robotic platform applies adhesive to the rim of the outer car door panel. Mechanical fingers of the robotic platform then dab adhesive at strategic location where it matches up the tubes and the steel bars that is constructed in the inner panel as they combine it with the outer car door panel. A special press then folds the lip of the outer panel over the inner panel afterwards, joining the car door panel together, as you can see in the third picture. This hemming gives the assembled car door another edge. Subsequently, the car door undergoes rust-proofing, paint, and other protective treatment before adding a chrome trim clipped in place on top of the joint panels. A worker then installs a small fixed window in the groove of the frame. A plastic protector is then used to prevent scratches as the worker installs another larger window glass that is processed earlier, slide into the slot between the car door panels and links it into a power lifting mechanism inside. The car door panels and the window mechanism are bolted together for more security, and the finished product is as shown in the last picture here. So this is the picture of a finished product of a car door after going through all the processes I explained earlier.
Assalamualaikum and hi, my name is Nur Ain and I will explain the defect that normally occur on manufacturing process. Manufacturing defect is a defect that was not intended to occur on the products. Okay, so the first one is casting process. A car door frame was made from die casting aluminum process, and during this process, there are numerous things to go wrong, resulting in the quality defects in the cast product. Okay, so the first one is flash defects. Flash defect was caused by the pressure of injection is too high and the force of grab is too low. Okay, so the solution to solve this defect is make sure that the pressure of injection is in moderation level. That means it's not too slow and it's not too high. Okay, so the second one is unfilled section. Unfilled section was caused by the insufficient shot volume. The injection is too slow and low pouring temperature. Okay, so the solution for this defect is make sure that shot volume is sufficient and the injection is not too slow. Okay, the third one is hot tearing. Hot tearing is the result of shrinkage, where the solidified material will crack when some part of the material is not allowed to shrink freely and encounters an obstruction. So in order to solve this defect, this defect can be easily resolved by modifying the mold to improve collapsibility. Okay, so the second one is joining process. There are two defects that we can identify from the process, where the first one is porosity. Porosity was caused by the surface or flat contamination and insufficient or pre-cleaning. So to solve this porosity defect is we must control the flow of air within the project area. So the second one is solidification cracking. Since the car door frame was made from aluminum and some aluminum alloys have wide range of solidification temperature, so they tend to crack during the welding process. In order to prevent this defect happen, we need to preheat the material, and the impurities on the metal must be removed before we start our welding. And last but not least, use proper joint design. Okay, so the third one is metal forming process. There are three defects that we can identify from this process, where the first one is wrinkles. Wrinkles form when the sheet metal stamping process creates compressive strain that push the material together. and it causes the overlap. So to solve this wrinkles defect is, instead of forming crushing without any pads or binders, it's better to solve it by stretching or drawing material. Okay, so the second one is split. Split is happen when the strength cause the material to thin beyond its depth limit. So to reduce this defect is, we can reduce this by considering the material type and so on. So the third one is spring back. Spring back is happen when in the state of stress and strength in the form of material has changed. So to solve it is, it can be solved by overbending or compensate the forming tool shape. Okay, so the fourth one is non-metal forming process. Bubble effects will occur when the glass was going through the laminating process. So when it going through the laminating process, um, it will cause the bubbles occur on the glass, especially at the edge of the glass. Okay, so the solution to avoid this defect, to solve this defect is, first we have to perfecting the pre-processing activities like cutting, washing, and so on. And the second one is carefully monitoring and measuring the steps. Number 4. The process of designing parts, components, or products for ease of manufacture with the end goal of producing a better product at a lower cost is known as design for manufacturing. Simplifying, optimizing, and refining the product design accomplish this goal. Okay, so the design consideration of casting process. The design of die casting is very tricky and it will affect the cost of manufacturing. So there are 3 basic points that need to be considered, include draft angle, parting line, and undercut. Draft angle is required for the parts to be ejected from the die. The range draft angle is between half degree until 1 degree. So the parting line is where the two halves of the die meets. And lastly is undercut. Undercut is happen as the die components become more complex and many features have been added into that components. So to solve this issue is to install the sliding core. The second one is design consideration of joining process. The first point is welding tool can access the entire area. That means the part should be designed so that the welding tooling can access the entire area above the weld joint. And the second one is the thickness of material must be consistent. The thickness of material should be uniform. That is because the transmission is slow and the thickness is increased. The laser lag that reach the joint will decrease. So that's why the thickness of material must be consistent. So the third one is the importance of clamping the weld joint properly. This is to prevent the welding that have been done on the metal is not done accurately. I mean, in order to weld accurately, so that's important to clamping the weld joint properly also. So the third one is design consideration of metal forming process. The first point is hole thickness. It is better to maintain uniform hole thickness for the whole body when designing any geometry. That is because the geometry with multiple hole thicknesses requires the use of sheets of various thicknesses too, which needs to reorientation and alignments the part. and it's simply to say it will take much more time to do that. And then the second one is K factor. The ratio of the nitro axis to the material thickness varies in value depending on the material physical properties and thicknesses. Design consideration of non-metal forming process. So the first point is wave watchers. Uh, the wave of window is major factor for small and low cost car, where if the window is too thin, it will affect the sound insulation. Meanwhile, if the window is too thick, it will affect the car maker's effort to achieve the full economic car and meet emission target. The second point is noise control. Glazing have been used to control the noise, since the glazing is now recognized as an important method of vibration and insulation. So, in other words, they will create laminated glazing sets with different acoustic for the windows car.
Hello, and we meet again. So, on to our last topic of the presentation, which is the optimization of the whole design of our product. This topic will be thoroughly explained by me, Loretta and Anak Duncan, and also my friend Nur Ain binti Morhaiji. So, on to the first point in the optimization, which is the optimization and casting process. As casting process is a process where molten substance is poured into a mold and let dry before the mold is taken away from the finished product, plenty of optimization steps are needed to be taken account in order to get a good finishing product. So firstly, my first point, which is the use of die casting simulation technology. The use of die casting simulation technology can be a good optimization option, as car door frames often comes with different shapes and different sizes considering the brands or the demands of the consumers. Die casting simulation is a computer-powered machine where manufacturers can update data such as the measurements and the parameters of the desired products of casted items. It allows designers to simulate with precision of the desired design, as well as identifying reactions behind the casting process as they facilitate the casting process. This simulation uses computational fluid dynamics, which is CFD technology, to facilitate the temperature of the casted items as they solidify. This allows the manufacturers to avoid defects, as the simulation allows them to control what is happening inside whilst casting. Another optimization steps that can be taken is by adding a subtle vibration to the die casting machine. By adding subtle vibration to the die casting machine, as the subtle vibration with certain frequency can reduce the amount of forming air bubbles, thus also refining the grain structure and reducing the grain size of aluminum alloy used in the casting. This method also increases the ultimate tensile strength and also the hardness of the material, hence optimizing the casting process as it reduces waste as well as increasing the quality of the product altogether. So the second optimization step is the optimization and joining process. Throughout the joining process of a car door, of the assembly of a car door, there are three types of joining processes that are involved, which is welding, bolting, and also used by the usage of adhesive. So there are plenty mistakes that could go wrong within the joining process, which consequently causing waste upon waste of materials when the product is not optimizing to top quality. Thus, optimization steps are needed in order to ensure the desired product is in a good shape. So, in the process of welding, parameters such as the welding speed and the welding current are needed to be measured and controlled to get the desired output. By using friction stir weld technology, which is the FSW technology, they can help getting the desired output needed for each product. As friction stir weld technology is where the welding tool is plunged and rotated on two pieces of products that are to be joined as it transverses along a joint line, making the material heat up and soften. By using this technology, it reduces defects as it provides almost close to none hot cracking, porosity, or solidification cracks. It also reduces shrinkage as FSW technology uses low temperature to join two workpieces together. No filler material also means saving in terms of cost and waste material, thus making it a good option to optimize welding processes of these aluminum frames from earlier processes. Next is the optimization of bolting process. Changing the rotation speed of the bolt, the size of the bolt, and also the temperature of the surrounding is one of the important factors of bolting optimization. The clamp length, or also known as the free length of a bolt stretched under tension, is to be at least 3 to 5 times of the bolt diameter. The increasing of elasticity of the fastener also helps in optimizing the bolting process as it can help reduce settlement effect where it increases the elongation of the bolt, reduce the risk of self-loosening, minimizing load transfer loss. And the third one, which is the adhesive optimization. Adhesive process can be altered and optimized by shape optimization. Shape optimizations are important in order to reduce waste, whereas increasing the strength of the adhesive so that the two joint workpieces does not fall off. So next point, I will be giving the presentation to Norain binti Morhaji to continue.
Optimization in non-metal forming process. So the umbrella and the other sources have been used to compile the optimization for the glass working, where first is compressive stress. The compressive stress in the glass is stronger than tensile stresses, so the component be met with should be met to withstand the compressive rather than tensile stress. The second one is since the properties of glass. Since the glass is so brittle, so it's better to not use the glass in application that involve high stresses in order to avoid the fracture on the glass. Optimization in metal forming process. Benele and Bindu stated that there have been two approaches to reduce the weight of a car, where the first one is to use lightweight steel instead of steel and make sure that lightweight is stronger than steel. Okay, so the first one is part disintegration method, where each section of length is then separately and then it will the two of that section that have been stamped separately will be welded together. And then the next one is integration method. The part from a single blank is stamped out. This method it will cut down the cost of assembly.
Okay, so I think that's all from our group 42, where the member is me, Ain, and Loretta. So thank you and bye bye.